Okay, I just want to talk to you about the method that I use for solving all motion problems. All motion problems can be solved this way, well, as long as we're not solving motion problems in terms of energy. When we get to energy, we're going to do that later. We can solve these in a different way, but right now we're going to solve motion problems using motion equations, and this is how to do it. First of all, it's a really good idea to draw a picture of the problem. That's going to be more for two-dimensional motion, for two-dimensional kinematics, where we have, for instance, a ball that's falling off the edge of a cliff, and we want to find out a lot of different variables about this, because there's an x dimension and there's a y dimension to its motion. That's good for drawing a picture. For one-dimensional motion, which is what we're going to do right now, it's not quite as important. It is for free fall, but we'll get there in a second. So when I have a problem about motion, the very first question I want to ask myself, before doing anything else is there acceleration in the problem? Is there acceleration? And we'll talk about in later videos how to recognize that. But if your answer is no, if there is no acceleration in the problem, the rest is very simple. You use V equals d over t. I recommend using the guess method to solve this problem, even though it may seem overkill for such a small formula. V equals d over t is the equation for constant velocity, and only for constant velocity. We cannot use V equals d over t for accelerated motion. So if we have constant velocity, you must use V over t. This is not for accelerated motion. The reason is because when you accelerate, that means you're changing speed. We have an initial speed and a final speed, and they're different. There's only one speed in this equation, therefore we can't use it to consider acceleration. If you ask yourself, is there acceleration, and the answer is yes, then we go to a new ball game. And this is a typo. This should say number 3. If the answer is yes, you go to number 3. Okay, yes, we have acceleration. Here's number 3. If we have acceleration, we use kinematics equations, again using the guess method. And here's what I mean by kinematics equations. Here's an equation chart for you. And I am now looking at these equations that say the 4 equations of constant acceleration. And that's these 4 right here. 4, 5, 6, and 7. These are also called the kinematics equations. Kinematics equations. We're going to get very familiar with these over the next few weeks. These are the equations we use to solve problems involving accelerated motion. Accelerated motion. So we're going to use these equations in order to do that. So once we know there's acceleration, we know there's going to be kinematics, and when we do that, the very first thing we need to do is list all the 5 possible variables in those equations. Well, if you look at these equations, looks like we have VF, we have VI, A, T, and we also have delta D. Those are the 5 equations that show up in these equations. I'm just simply going to write those down, and you can think of them this way: A, T, VI, VF, delta D. Miss Freeman came up with this. I will give her credit on this. If you just say very fast to yourself, ATVVD, ATVVD, ATVVD. Say that very fast, and you'll never forget what these 5 variables are. But the 2 D's, remember, one is VI, one is VF, or the 2 V's, sorry. The D refers to the delta D, and I'll refer to that as delta D, or sometimes I'll call it distance. Sometimes I will also call it displacement. All right, ATVVD. Once you do that, you go through all of these. You go down the list and you ask yourself, do I know A? Do I know T? Do I know VI, VF, delta D, etc.? You identify your givens and your unknowns. You write it down, or you put a question mark by it if you don't know it. At this point, you need to remember to think about the direction, indicating it with negatives and positive, and if you need to convert, do it at this point. Once you've figured out what you're given and what your unknowns are, your next question you ask yourself are, how many unknowns do you have? You will either have 1 or 2, never 3. You will never have 3 unknowns. If you did something wrong. If you only have 1 unknown, it's real simple. All you have to do is pick any equation that has your unknown in it. That's very important. For instance, if we're solving for delta D, I cannot use equation number 4. Number 4 doesn't even have delta D in it, so I can't use it to solve for delta D. But if I'm solving for VF, I can use 4. I can also use 5. Can't use 6. I can use 7, because 7 has VF as well. As long as I have everything else and only VF is what I'm looking for, I can use any of these that have my equation and it'll work. You will come out with the same answer as long as it has your unknown that you want. You will come out with the same answer if you do the algebra correctly. That's if you have 1 unknown. If you have 2 unknowns, which happens quite commonly, it gets a little bit more complicated. If you have 2 unknowns, you first have to decide which unknown you need. Which one do you want? In other words, which one is the problem asking for? Which one is the problem asking for? Once you decided which one you want, that is the one that you circle. So say our 2 unknowns might be VF and delta D, right? Let's say the problem is asking for final speed. I'll circle final speed, and I'm going to cross out the other one because I call it my I don't care variable. I don't care about delta D. I don't need it. I want VF. I don't care about delta D. And that's important to know because when you find an equation, there are 2 criteria that we need to meet to find an equation. First of all, number 1, we have to have the variable that we want. My equation has to have the variable that we want. So if it's in this case, it has to have VF. So I want you to notice, well, let me go there next. Has to have VF, and it cannot have the variable that we crossed out, the variable that we don't care about. So in this case, we would want to find an equation that has VF and not delta D. Look over here at our equations, and you'll notice that each one of these equations is missing one of those variables. This one doesn't have delta D. This one doesn't have A. This one doesn't have VF. This one does not have T. So let's look at what we have here. We want VF. We don't care about delta D. So I'm going to look for an equation that has VF and does not have delta D. I'm going to look down here. VF is here, it's here, and it's here. Among those 3, which one does not have delta D? Both of these do. I cannot use those. I want to use this one. VF equals VI plus AT. That's how to pick an equation. So let's just run through this example problem down here just to show you how this works. This problem is a ball is thrown upward with a speed of 25 meters per second. I want to know how long it takes for the ball to reach its max height. First thing it says, draw a picture. That's what I did. Here's my picture. Ball is thrown upward. The velocity at the bottom is 25 meters per second. That's what we start with. Maximum height is here. Second, number 2, I asked myself, is there any acceleration? Well, yes, there is. There is acceleration because of gravity. As the ball nears the top, you may remember that it will slow down. That's acceleration. And gravity is what's causing it to slow down. Number 3, I'm going to list all my variables, and that's A, T, V, V, D. A, T, V, V, D. So I list them and I go through the problem. Do I know delta D? No. There is no distance or displacement in this problem. Do I know A? Yes, I do. If it's a free fall problem, which gravity is, and we'll talk about those in another video, my answer for the acceleration is negative 9.8 meters per second squared. That's always true for gravity, for the acceleration due to gravity. My initial velocity, to start out with, I have a speed of 25, so there's my initial velocity, and I need to think about direction when I'm in this case. This velocity is going upward. That's in a positive direction, so I'm going to make this positive. Final velocity is 0, and I know that because at the maximum height, the ball has to stop for just an instant before it begins to come back down. So my final velocity will be 0. Time, I don't know from the problem. We don't need to do any conversions. All our units are correct, but we need to make sure and check it before we finish. How many unknowns? I have 2. 1, 2. So we pick an equation that has the one that we want and not the one that we don't need. We know we're looking for time, so I'm going to circle that one. Therefore, I don't care about delta D. I don't need delta D. Cross it out. I don't care about it. Find an equation that has time and not delta D. Well, the only equation that has time and not delta D will be number 4. VF equals VI plus AT. We write that equation down, substitute, and then solve. 0 is VF, VI is 25, A is negative 9.8. Subtract 25 from both sides, that gives us negative 25 equals negative 9.8 T. Divide by negative 9.8 on both sides, and your answer will be 2.6 seconds.